In this expression, we have the power rule. We have a power raised to another power. So in this case, we multiply the exponents. So it's going to be x to the 1/5 times 1/4. When multiplying exponents, we multiply straight across. So it's going to be x to the 1/5 times 4, which is x to the 1/20. When multiplying two expressions with the same base, we add the exponents. So we're going to have x raised to the 1/5 plus 9/5. When we add exponents, we want to make sure that we have common denominators, which in this case we do. The denominators are 5. So now all we have to do is keep the denominator the same and then add the top. So the final answer is going to be x to the 10/5, and of course 10 divided by 5 is 2, so the answer is x to the second power. For this problem, we need to add the exponents. So we're going to keep the base the same, and we're going to add 2/7 plus 1/3. When adding fractions, we need to make sure the denominator is the same, which in this case it isn't. We have a 7 and a 3. So we want to get common denominators. So let's change the denominator to 21 in both of them. And then to get 21 from the 7, we're going to multiply by 3. So we're going to do that to the top and the bottom. And then 3 times 7 is 21. Do that to the top and bottom. So now we have x raised to the 6/21 plus 7/21. Now that we have the same denominators, we're going to keep them the same, and then we're going to add the top, 6 plus 7. So we have x raised to 13/21. And since 13/21 can't be reduced further, this is our final answer. To solve this operation, we need to subtract the exponents. So we're going to start with keeping the base, which is x, raised to 1/2 minus 5/2. When we subtract fractions, we need to make sure we have common denominators, which we do in this case. So we're going to keep the denominator the same and subtract the top. So we have x raised to -4/2. Now, -4/2 is -2. So we have x raised to the -2nd. And we don't want to have a negative exponent, so we're going to continue, move it to the bottom, and our final answer is 1/x to the 2nd. To multiply these two expressions, we want to rewrite the radicals into rational exponents. So to do that, the first one is going to be x raised to the 1/5 times x raised to the 1/6. Now we're multiplying these two expressions. They have the same base, so we're going to keep the base and add the exponents. So when we add the exponents, we've got 1/5 plus 1/6. And when adding fractions, we need to have common denominators. You can see here the denominators are different. So we need to get common denominators, and let's go with 30. So we're going to get equivalent fractions with the denominator of 30. So 5 times 6 gives me 30. So we're going to multiply by 6 at the top. 6 times 5 equals 30. Multiply by 5 at the top. So we're going to arrive with x raised to the 6 plus 5 over 30. So we have x raised to 11/30. Now we could leave our answer as it is, or we could go further and write it back into radical form. So if we wanted to do that, then remember that the numerator of the exponent is your exponent in radical form, and the denominator is the index number in radical form. So we could write it as the 30th root of x to the 11th. These two are equal. As the problem is written now, we cannot divide anything, but we can convert these radical expressions into rational exponents, and then we'll have the same base, and then we can simplify. So the numerator we can change to 11 raised to the 1/2, and the denominator we can change to 11 raised to the 1/3. Now that we have the same base and we're dividing, we can just keep the base and subtract the exponents. 11 raised to 1/2 minus 1/3. Now, let's focus on those exponents. So, to subtract fractions, we need to have common denominators. So let's work with that. 1/2 minus 1/3. We want to change that to get common denominators of 6. And so we're going to multiply the first fraction by 3/3 and the second one by 2/2. So we've got 3 minus 2/6, which equals 1/6. So we have subtracted 1/2 minus 1/3, so the final answer is going to be 11 raised to the 1/6. We could leave our answer like that, or we could continue and write it back into radical form by saying that is the 6th root of 11. Both answers are equal. So for this problem, we want to distribute x to the 1/6 to each term in parentheses. So we have x to the 1/6 times x to the 5/6 plus x to the 1/6 times x to the 2nd. And now, when you are multiplying two expressions with the same base, we're going to add the exponents. So we have x to the 1/6 plus 5/6 plus x to the 1/6 plus 2. So the first addition already has common denominators. So we just add the top and keep the denominator the same. So that's going to be x to the 6/6. Plus, here we do not have common denominators, so let's get common denominators. So let's put the 2/1, and we can get a common denominator of 6. So we can multiply the top and bottom by 6. So we're going to end up with x to the 1/6 plus 2 times 6 is 12/6. Now let's continue on. So 6 divided by 6 is 1. So we have x to the 1st plus, let's combine here, 1/6 plus 12/6 is x to the 13/6. And then finally, x to the 1st is just x, and then we have plus x to the 13/6. Now, we can't add this further because although they have the same base, they do not have the same exponent. So they would have to have the same exponent and base in order for them to be like terms. So this is our final answer, x plus x raised to the 13/6. To perform this indicated operation, we need to start by distributing x to the 1/10 to every term in parentheses. So we have x to the 1/10 times x to the 3/10 minus x to the 1/10 times 7x plus x to the 1/10 times 4x to the third. So if we look at the first product, we're multiplying two terms with the same base, so we're going to add the exponents. And the exponents are already set up to have fractions with the same denominator, so all we need to do is keep the denominator the same and add the top. 1 plus 3 equals 4. Now here in the second product, we have x to the 1/10 times 7 times x. So remember that this x has an exponent of 1. And so if we're going to keep that minus 7 as the coefficient, and then we have x to the 1/10 plus 1, because they do have the same base, so we're going to add the exponents. And we'll simplify this later. And then over here, the last one, we're going to keep that 4 coefficient. And again, we're multiplying x to the 1/10 times x to the third, because remember that multiplication is commutative, so we can change the order around and still get our correct answer. So we have the same base x and x, so we're going to add the exponents. 1/10 plus 3. So let's simplify 4 over 10. That's going to give me x to the 2/5. Now 1/10 plus 1, let me change 1 to be 10 over 10. So if we keep the denominators the same, which is a 10, and then we're going to combine the top, 1 plus 10 is 11. And let's focus on the third term. So we have, and I forgot an x here. Okay, the base for 1 over 10 plus 3 is an x. Now, we need to add 1 over 10 plus 3. We need to get common denominators. So we're going to change 3 to be 30 over 10. So we have 1 over 10 plus 30 over 10, which equals 31 over 10. So our third term is going to be plus 4x raised to 31 over 10. And so now we just want to double check and make sure that we can't reduce anything further. And 2 over 5 is reduced, 11 over 10 is reduced, and 31 over 10 is reduced. So our final answer is x to the 2 over 5 minus 7x to the 11 over 10 plus 4 times x raised to 31 over 10. To perform this operation, we're multiplying a binomial times a binomial. So in this case, we want to distribute, or shortcut is to FOIL. First, outer, inner, last. So let's start with the first. So x to the 1/2 times x to the 1/2, outer, plus 7 times x to the 1/2, inner, plus 5x to the 1/2, and then last, plus 5 times 7. So let's continue. So x to the 1/2 times x to the 1/2. We're multiplying exponents with the same base, so we're going to keep the base and add the exponents. And so that's going to give us x to the 2 over 2, which of course is 1, plus, bring down the 7x to the 1/2, plus 5x to the 1/2, plus 5 times 7 is 35. Now, in the middle here, we have like terms because they have the same x and exponent. So that means we're just going to add 7 plus 5 and keep those like terms, x to the 1/2. So we're going to end up with x plus 12 x to the 1/2 plus 35. Now, even though these first two terms have an x, they're not like terms because they do not have the same exponent. This x, remember, has an exponent of 1, and this x has an exponent of 1/2. So we have our final answer.